Have you ever been craving strawberries, but when you go into the refrigerator at home, all of them are moldy? Well, I've had this problem tons of times, so I decided to do an experiment to determine what makes strawberries mold quicker. One day when I went to the grocery store and brought strawberries home, my mom told me not to wash the batch of strawberries immediately because she said exposure to moisture makes them mold quicker. And I wanted to know if her statement had any valid reasoning behind it. So I did an experiment testing whether strawberries that have been rinsed mold faster than strawberries that haven't been rinsed. And in order to prevent any confounding or minimize the effects of lurking variables, I blocked by whether the strawberries are organic or not. To begin my experiment, I went to Walmart and bought a pack of organic strawberries from the same brand as the pack of non-organic strawberries that I bought. When I brought them home, I got rid of all the strawberries that exhibited any bruising or mold, and then I randomly assigned the strawberries from the organic pack into two different treatment groups. One treatment group would be being rinsed and the other treatment group not being rinsed. Then I randomly assigned the strawberries that weren't organic to the same two different treatment groups. After I rinsed the strawberries in the organic rinse group and the non-organic rinse group, I put them all into the same containers and placed them in my refrigerator, which is at temperature 4 out of 9, 9 being the coldest, 0 being off. I wanted to do more than just check the proportion of strawberries that were molded at the end of the experiment. So I measured the progression of mold in each treatment group. Every 2 days, I checked the strawberries containers to see how many strawberries had developed mold. The result of my findings are displayed in 4 graphs that are included in the research paper. The non-organic no-water treatment group showed that 1 strawberry molded after 2 days, 4 strawberries had molded after 4 days, 5 strawberries had molded after 6 days, and 7 strawberries had molded after 8 days. The non-organic with water treatment group showed that 2 strawberries molded after 2 days, 6 strawberries molded after 4 days, 6 strawberries molded after 6 days, and 7 strawberries molded after 8 days. The organic no water treatment group showed that 0 strawberries molded after 2 days, 1 strawberry molded after 4 days, 2 strawberries molded after 6 days, and the total of 4 strawberries molded after 8 days. And finally, the organic/water treatment group showed an approximately linear line having 1 strawberry mold after 2 days, 2 strawberries mold after 4 days, 3 strawberries mold after 6 days, and 5 strawberries mold after 8 days. What was I doing? Finally, after 8 days of letting the strawberries sit in my refrigerators, I took a final sample and determined the proportion of strawberries that had molded in each treatment group. The first hypothesis test I did was for the non-organic strawberries. My null hypothesis is that the proportion of strawberries that weren't exposed to water equals the proportion of strawberries that were molded that were exposed to water. And my alternative hypothesis is that the sample proportion of strawberries that were exposed to water is greater than the sample proportion of strawberries that molded that weren't exposed to water. And my alpha level was 0.05. The p in my null hypothesis equals the true population proportion of non-organic or organic strawberries that have been rinsed or otherwise exposed to water after being purchased that have molded after an 8-day period. And for the no water, it's the true population proportion of non-organic strawberries that have not been rinsed or otherwise exposed to water after being purchased that have molded after an 8-day period. After I did my plan step, I realized that the random condition is satisfied, but the normal and independent conditions are satisfied. Although the normal condition was not satisfied, the procedure is robust. And we actually did not want the independent condition to be satisfied, because although whether or not 1 strawberry molds is not an event that's independent of another strawberry molding, we want we don't want these events to be independent because we're measuring the total proportion of strawberries that molded after a certain number of days. And if one strawberry molding ruins the rest of the batch, then we want this to be included in the study. So this is a good thing that it didn't meet the independent condition. After doing the do for the non-organic hypothesis test, I got a z value of 0.386, which is relatively lower than I was expecting. And the p-value ended up equaling 0.349. This means that if we were to get a sample, like a sample of that amount would be this far or further from the null hypothesis of the difference being 0 34.9% of the time, which is relatively high. And since our p-value of 0.349 exceeds the alpha level of 0.05, we fail to reject the null hypothesis. There is insufficient evidence to conclude that the true population proportion of non-organic strawberries that have been rinsed or otherwise exposed to water after being purchased that have molded after an 8-day period is different from those of the non-organic strawberries that were not rinsed. My hypothesis test for the organic strawberries came with a relatively similar result. My null and alternative hypothesis were the same, and so was my alpha level. And the P's represent the same thing, except for this time they are organic strawberries that have been rinsed or not. In my plan, each condition was satisfied the same way. Random was satisfied, so we are allowed to assume causation and not just correlation. Normal was not satisfied, but the procedure is robust again, so we will continue. And once again, we are happy that the independence condition is not met because we're determining the overall amount of strawberries that were molded, not just one strawberry. And if one strawberry affects another strawberry, then we want this included in the results of the experiment. For my do in the organic hypothesis test, I got a z of 0.558. This is higher than the z in the non-organic group, but it still produced a relatively high p-value, and this time the p-value was equal to 0.288. And this time our conclusion is that since our p-value of 0.288 exceeds the alpha level of 0.05, we fail to reject the null hypothesis. There is insufficient evidence to conclude that the true population proportion of organic strawberries that have been rinsed or otherwise exposed to water after being purchased that have molded after an 8-day period is different from the true population proportion of organic strawberries that have not been rinsed or otherwise exposed to water after being molded for 8 days period. As you can see, for the results of my experience, we failed to reject the null hypothesis twice. In my own experiences, I was expecting us to accept the alternative hypothesis because I have noticed in a non-experimental basis that when the strawberries are rinsed, they mold quicker. But there are other contributing factors, like if I would have left the strawberries outside of the refrigerator and they weren't being preserved like that. Other factors like if I would have kept the strawberries in the original containers, as I only had 2 of the store-bought containers, I had to put them in Tupperware, so that could have affected the experiment as well. Other things that could have affected it were the temperature of the refrigerator. I put them in the refrigerator that was outside in my garage, so this could have had an effect. And also the number of strawberries that had started molding beforehand. Although I got the strawberries from the same brand, the organic strawberries and the non-organic strawberries were located in a different part of the store in Walmart. So one of the boxes could have been older and the other box could be a little bit fresher. So this could have contributed to the amount of strawberries that, how the strawberries molded and how the mold progressed. So, one moment. So, these are some of the strawberries that were used in the experiment. I kept some of the bad ones. Like you can see, this one is really nasty. It's got a little bit of mold on it. It's kind of really disgusting. And this one's like falling apart. Ugh. So that is my stats experiment. This was a TED Talk about strawberries and how they mold and how the progression of mold is. And it also shows how the difference of molding between non-organic and organic strawberries happens. Although for the treatment groups, we didn't see enough of a difference to accept the alternative hypothesis. We also did not accept the null hypothesis, so we failed to reject it, which means the null hypothesis might not be true. So given another experiment, we might find that water or exposure to moisture actually does have an effect on how many strawberries mold after a certain period of time.